So there was a problem with the previous video, so I cannot put it on Canvas, but this one should be fine. So let us review what is an integrating factor, right? So in the previous class, we learned how to derive an integrating factor to solve an inhomogeneous differential equation. So we have what? We have x prime plus p t of x times x, and this is equal to ft. Now we're going to learn the general method, the general formula for the integrating factor, right? And now general formula. And this is what you can memorize when this is a formula that you should memorize when you encounter an inhomogeneous differential equation of first order and linear. So the integrating factor, factor has the form qt is e to the let's say kt. So we're gonna have an integrating factor of this form, and then we multiply both sides with q, both sides of the equation. With q, right? So so you're gonna have qt times x prime plus qt ptx, and this is equal to qt ft. So this is a way that we have a general formula for the integrating factor. Suppose that we want to solve this equation: x prime plus pt is equal to ft. So what we do is we multiply both sides of the equation with an integrating factor qt, which is of this form, e to power pt. So you're going to have qt times x prime plus qt ptx is equal to qt ft. Now we have what? We have e kt x prime plus e kt times pt x, and this is equal to qt ft. All right? Because we choose qt to be of the form e to the kt, I can replace qt by e to the kt, and I'm gonna have e to the kt times x prime plus e to kt times pt times x, and this is equal to e to the kt ft, right? So now we choose k such that k prime t is equal to pt, right? Now I'm going to choose k such that k prime t is equal to pt, and this is what you have to solve. Then you're going to have e to the kt x prime plus e to the kt k prime of t x, and this is equal to kt ft. So here I replace pt by k prime of t, right? So I explain again. So here I have e to the kt times x prime plus e to the kt pt x, and this is equal to e to the kt ft. I'm going to choose kt such that k prime of t is equal to pt. So I have to solve this equation, right? So, in other words, kt will be the antiderivative of pt. So this is the function that you should choose. So when you choose kt to be the antiderivative of pt, you're going to have e to the kt is x prime plus e kt k prime, because here pt is equal to k prime, right? And this is equal to e to the kt f. Now you observe that, okay, e to the kt k prime of t is nothing but e to the kt prime. Now you observe that this guy is e to the kt, and you take the prime. So this you can write under this form. So you have e to the kt x prime plus e to the kt prime x, and this is equal to ft, right? So you observe that e kt k prime is e kt prime. You replace that by e kt x prime, and this is e kt prime x is equal to ft, right? But this is the product rule. So you have e kt x prime is equal to ft, right? And you integrate both sides. You can solve x. This is the formula that we can use to solve linear and inhomogeneous differential equation. So the general form of the integrating factor will be e to the kt, which is e to the antiderivative of bt. And when you multiply this integrating factor into the equation, you're going to have e, the antiderivative of pt, mt, x, sorry, and you take the prime, and this is equal to pt. This is the formula that you can use. X prime again. You have to solve the equation x prime plus pt is equal to ft. What you can do is to multiply both sides with a factor qt to change it into this form. So how do we do it? So when you multiply this qt to both sides of the equation, so qt should be of the form e to the kt. And the reason why I choose e to the kt was because of the last class, because you solve a separable equation, and then because you have 1 over x, which gives you a log as the antiderivative. So you have to take an exponential, right? But here I just give you a brief formulation. So you're gonna take qt of the form e to the kt, and then so you're gonna have e to the kt x prime plus e to the kt times ptx, and this is equal to e to kt ft. You're gonna choose k such that k prime is equal to pt, which means that kt is nothing but the antiderivative of p. And here you're gonna have e kt x prime plus e kt k prime x. The sum is equal to e kt ft. All right? Now this product e kt k prime is e kt prime. I can write it this way, and I replace that by e kt x prime, e kt prime x is equal to ft. But this is the product rule, right? So you're going to have e kt x prime is equal to ft. Yes?
Should it be e kt x prime plus e kt prime x equals f times e to the kt?
Yes. Thank you. Yes. Yes. Can you sign in the back of this? Other questions? Right. So this is the formula that you can use. You can choose the integrating factor to be qt is equal to exponential of the antiderivative of pt, and you multiply and you get this equation. And why do we have to choose qt out of from e to the kt? This was because last time we identify the coefficient and we get q prime over q is equal to something. You take the antiderivative, you have log of q is equal to something, and which means that q should be exponential of something. Right? It's clear? Questions? Now, using this formulation, we can solve the last exercise easily. So in the last exercise, we have what? In the last exercise, we have x prime minus 3 over tx is equal to t to the power 4. This is what we try to solve. In this case, pt will be minus 3 over t, and ft will be t to the power 4, right? Right, so in the previous exercise, we have x prime minus 3 over tx, and this is equal to t to power 4. You identify with this form, you're going to get pt is going to be minus 3 over t. And you're going to get ft is going to be t to the power 4. All right? Now, what is the integrating factor? Yes?
It would be e to the integral of pt, so it would be e to the integral of minus 3 over t.
Right. Inside the bracket of this. So qt in this case will be e to the integral of pt. This is e to the integral of 3 over t. Right? So this is going to give you e to the power minus 3 log t. And so I'm going to choose only one value. So this is t to the power minus 3. This should be a constant, but here we only need to choose one function. And this is going to work. So we choose only one. We can forget the constant in this case. All right? So I explain again. So I'm going to use this formula. So in the previous class, we learned how to derive this formula. But here, we just try to use this formula to understand the meaning of the formula. So in this case, Q will be E, the antiderivative of PT. PT in this case is minus 3 over T. So the antiderivative of this guy is T to power minus 3. Right? So when I multiply this QT to the equation, I'm going to have T to power minus 3. So I'm going to write the other equation over here. So you have E to power P xt prime is equal to ft, E to the power pt. Right? So this guy is T to power minus 3x prime, and this is equal to T to the power 4 times T to power minus 3, and this is equal to T. Right? Now I'm going to use this formula. I use this formula, I have E to the power antiderivative of pt times x, and you take the prime, and this is equal to ft, e to the power of the integral of pt. So the first guy gives me t to power minus 3, so I put t to power minus 3 here. F is t to power 4, so I have t to power 4, t to power minus 3, so this gives me t. So I have to solve this equation. So I have what? I have t to the power minus 3x, should be t squared over 2 plus c, which means x has to be t to the power 5 over 2 plus c, t to the power 3. All right? It's good. Here I have t to the power minus 3x prime is equal to t. I take the integral on both sides. I'm going to have t to the power minus 3x is equal to t squared over 2 plus c, which means that x is t to the power 5 over 2 plus c, t to the power 3. It's clear? Questions? Right, so far we have learned two methods. The first one is separable, and the second one is integrating factors. The integrating factors has a complicated derivation that we learned from the previous class, but today we have a simpler one. This one is, of course, based on the previous complex computation, but it's simpler. And this formula is the one that you can use in the homework or in the exam, right? If I ask you to derive it, then you have to do it, but otherwise you can use it. Questions? It's clear? Right, so if there is no questions, let us try to do homogeneous linear differential equation. So I'm gonna keep this to our y. Right. So 1.7.1 constant homogeneous constant coefficient linear differential equation. Right, now we want to learn something easier. This is homogeneous, which means that you have x prime plus k, x is equal to 0. So this is homogeneous. All right, this is homogeneous because f is 0. This is linear because this term is linear. All right, and we have constant coefficient, right? So which means that this has to be a constant. This is 1.7.1 in the book. So we have constant coefficient linear differential equation. So constant coefficient means that here the function k has to be a number, and this is linear. So you have k times x. This homogeneous. So the f has to be 0, right? So how can we solve this equation? Anyone else? Yes?
I feel like it's still probably using the integrating factor.
Right. So this is going to be integrating factor, but this is the easiest one. Right. So what is the integrating factor? Can you say in the back? So what is the integrating factor in this case?
E to the integral of k, which will just be e to the kt.
Yes, excellent. Can you say at the back of the paper, please? So in this case, the pt, right, will be k. What you do is you take the antiderivative of this guy, so the integral of pt will be kt. So the integrating factor will be e to the kt. All right? So the coefficient in front of x, pt, will be k. You're going to take the integral of pt. This gives you kt. So integrating factor is e to the kt. Now I'm going to check this. Checking. You have e to the kt. So multiply with e to the kt. All right? So now you multiply both sides of the equation with e to kt. You have e to the kt x prime plus e to the kt times kx is equal to 0, right? So what is e ktk? Sorry?
That's not the right answer.
Any other answer? So what is EKT times K? This is the derivative of what? Yes?
It's the derivative of e to the kt.
Yes, can you stand the back? This. So this is e to the kt prime, right? E to the kt. Right? So this is the whole point. You're going to change the left-hand side to a product rule, to something that so that you can use the product rule, right? So which means that this guy, you have to change this guy into a derivative. So e to the kt times k will be e kt prime. So e kt prime is of course k kt, which means that you have e kt x prime plus e kt prime x. This is 0, right? So when you use the integrating factor, you're gonna get this derivative for free, right? So this you're gonna use the chain rule. So you have e kt x prime is equal to 0, right? So here I use f g prime is f prime g plus f g prime. Right, so this is the product rule. So at the end of the day, I'm gonna have e kt x prime is equal to 0, right? What is the solution of this equation? E kt x prime is equal to 0. Yes?
X equals negative e.
Yes, can you say the back of the paper, please? You're gonna take the antiderivative of 0, right? So you have what e kt. E kt will be the antiderivative of 0, which is c. X, which is c. So x will be c e to the power minus kt. All right, so this is the solution of a homogeneous equation, linear equation, in which the coefficient is a constant. I explain again. If you use the formula that we have in the beginning, the coefficient pt will be k. You're gonna get pt is equal to kt, right? The antiderivative of pt will be kt. So the integrating factor will be e to the kt, right? Now, you multiply both sides with e to the kt. You're going to have e kt x prime plus e kt kx is equal to 0. But this guy gives you e kt prime, so you're going to apply product rules. So you have fg prime is equal to f prime g plus fg prime. So in this case, f is e kt and g is x. This gives me e kt x prime is equal to 0. So the function whose derivative is 0 should be a constant function, right? So e kt x has to be constant. So x has to be c e to power minus kt. And this is the simplest equation that we can have. Questions? It's clear? Right. And by the way, I put the homework one online. So the homework one is given today on Canvas, and we're gonna collect the solution for the homework tomorrow. No, next week on Thursday. And after the homework, I'm gonna put the solution online, right? And I'm gonna give you homework too. Okay, questions? So, homework one will be taken from the book. So it's better that you use the right version of the book. All right? Right, so 1.7.2. So this is the simplest first order differential equation, because the coefficient is constant, and this is homogeneous, this is linear. Now we have constant coefficient, linear differential equation with constant input of force. Now we have constant coefficient linear differential equation, but the input is a constant, and the force is a constant. We're going to have this form. So x prime plus k times x is equal to I. Right? So this is constant coefficient. And this is constant input upon force. This equation is a little bit more difficult because the input is not 0. But it's going to be the same because you have a constant coefficient, and so you have x prime plus kx is equal to this constant. Let us try to solve for an example. So you have x prime plus 8 of x is equal to 9. Right? What is the integrating factor in this case? Yes? Yes, excellent. Can you say at the back of the paper, please? So what you can do is, okay, you look into the coefficient 8. So strategy, we look into the coefficient of x, which is 8, right? So the strategy is that you look into this number 8, which is the coefficient of x. Now you take the antiderivative. The antiderivative of 8 is 80. So the factor, the integrating factor is e to the 80. This is basically how you find integrating factor. You just look into the coefficient of the x, which is the number 8. Just take the antiderivative, which is 80, and the integrating factor will be exponential of this function, right? So let us check. Now I multiply both sides of the equation with both sides with e to the 80. All right. Now I multiply both sides of the equation with e to the 80. I'm gonna get e to the 80 x prime plus 8 e to 80 x, and this is 9 e to 80. Right? So to find the integrating factor again, you just look into this number 8, you take the antiderivative, which is 80, and you take the exponential of that function. Now we're going to check. We have e to 80 x prime plus 8 e to 80 x, and this is equal to e to 80. So what is 8 e to 80? Well, what is this? Yes?
With those two, it's essentially the aftermath of the chain rule of the quantity of e to the 80 times x.
Right. Can you stay at the back of the paper, please? So this is product rule, right? Not chain rule. So this you're gonna need the product rule. So here you're gonna have e to the 80 prime, right? So 8 e to the 80 will be e to the 80 prime. So what you have is e to the 80 x prime plus e to the 80 prime of x, and this is equal to e to the 80, right? This is product rule with, so you have fg prime is f prime g plus fg prime. All right. In this case, f will be e to the at, and g will be x. Right. So this is product rule. All right.
I was trying to do the e to the 18, because when we do we take the derivative of the e to the 18, the 8 is the part of the chain.
Right. Yes. This is the chain rule, right? Yes. This is chain rule. From here to here, this is chain rule, right? You're right. This is chain rule. So from here to here, this is chain rule. So e to at prime will be e to at prime plus prime of at, which is 8. Right. So here you're gonna get e to the at x prime plus e to the at prime x, and this is 9 e to the at. So you're gonna use the product rule. You're gonna get e to the at x prime, and this is e to the at. All right. So what is the solution of this guy? So how do I solve this equation? Yes?
You'll integrate both sides and then solve for x.
Yes, can you say the back of the question, please? Now you integrate both sides, right? So you have e to the at x, and this is the antiderivative of e, 9 e to at, which is 9 over 8 e to at, plus a constant c. All right. So to solve this guy, you integrate both sides. The left hand side give me e to at x. The right hand side give me 9 over 8 e to at plus a constant c. All right. So now I'm gonna solve for x. So x is going to be 9 over 8 plus c e to the power minus 80. All right. It's clear? Questions? Yes?
How did you go from on the right side, how did you get that top step all the way to the top?
So this one,
No, the first line.
this one,
Yeah, how did you go from that to the step below?
from here to here.
Yeah.
I'm gonna apply the chain rule, right? So this is my f. All right. This is so f is going to be e to 80, right? This guy is g prime because g is going to be x. This guy is f prime, right? Right? And this guy is g. So what do I have? I have fg prime plus f prime g. I apply this formula. So fg prime plus f prime g will be fg prime. So this is f, and this is g. So the whole thing here will be fg prime, right? So e to the at x prime plus e to the at prime x give me e to the at x prime. That's good, right? So, so here this is the product rule, and after you have this, you can solve by integrating both sides. Other questions? So the key idea here is how to choose the integrating factor. The integrating factor is chosen by looking at the constant or the coefficient of x. In this case, this is a. You take the antiderivative of this guy, this gives me a t, and the factor will be exponential of this function, right? So after I have e to the at, I multiply everything by e to the at. I can turn the left-hand side into one derivative using the product rule, and after that, I integrating both sides and I solve the equation. Right? Questions? It's clear. Now let us try to go to a more difficult equation, which is you have what now? Constant coefficient linear differential equation. With exponential input. All right. The form. So in this case, I have x prime plus pt x, and this is going to be b e to the t. Right. So this p will be a constant. So this is constant coefficient, and this is exponential. So the next example will be constant coefficient linear differential equation with exponential input. So the coefficient has to be constant. This means this is constant, and the input is exponential. So you have exponential here, right? So let us try to solve this equation. So you have example, x prime plus 2x is 4 e to the 70. All right? This is the equation that we want to solve. All right? So you have x prime plus 2x is equal to 4 e to the 70. So what is the integrating factor? Integrating factor. Yes? Yes, can you sign the back of the paper, please? So the integrating factor will be e to the 2t. Why? Because in this case, the coefficient of x is 2, right? You take the integral of 2, right? So antiderivative. You get 2t, right? And then the factor will be exponential of this guy, e to the 2t. All right? So this is very simple. But here, if you have if you have t squared, you're gonna take the antiderivative of t squared, which is t cubed over 3, and the factor will be exponential of t cubed over 3. Right? Now the integrating factor will be e to the 2t. So I'm gonna multiply both sides with e to the 2t. I have e to the 2t plus 2 times e to the 2t x, and I have 4 e to the 70 times e to the 2t, which is 4 e to the 90. Right? I multiply both sides with this factor. I'm gonna have e to the 2tx prime plus 2 e to the 2tx, and this is equal to 4 e to the 70 e to the 2t, so this gives me 4 e to the 90. All right? So what is this 2 e to the 2t? Yes?
The derivative of e to the 2t.
Yes, can you sign the back of the paper, please? So this guy will give me e to the 2t prime. All right? These guys give me e to the 2t prime. So I can write e to the 2tx prime plus e to the 2t prime x is 4 e to the 90. All right? So what can we write on the left-hand side? Yes?
e to the 2tx and
Prime. Can you sign at the back of the paper, please? So the left-hand side, I'm gonna write like e to the 2tx prime, and this is equal to 4 e to the 290. All right? So from here to here, this is chain rule. From here to here, this is parabol. Now, how can I solve this equation? Yes.
Integrate both sides.
Yes, can you sign in the back of the paper, please? So you're gonna integrate both sides, and this give me. So what is the antiderivative of 4 e to the 90? Yes?
C to the 90.
Yes, can you sign in the back of the paper, please? So we have 4 over 9 e to the 90 plus c. All right? So you take the antiderivative of this guy. This is 4 over 9 e to the 90 plus c. All right, so x will be 4 to the 9 e to the 70 plus c e to the power minus 2t. All right? So I explain again. Okay, integrating factor is easy. You just have to look into the coefficient of x to take the interval. So this is 2, so the interval of that will be 2t. The integrating factor will be exponential of 2t. Now I multiply both sides with this exponential. I have e to the 2t x prime plus 2 times e to 2t x, and this is equal to 4 e to the 90. So 2 e to the 2t is e to the 2t prime, and this is why we have to choose the integrating factor of this guy, of this form. Right, so this is why here you choose antiderivative of 2. Now you use the product rule. You change everything into the e to the 2t x prime is equal to 4 e to the 90. Now to solve this, you just have to integrate both sides. It's clear? Questions? Right, so I have I have 127.4, which is constant coefficient differential equation. Discontinuous input. Discontinuous input. All right. Example, I'm gonna have e to x prime plus 3x is equal to gt. And then here I'm gonna have an initial condition. I have x0 is equal to 0, and gt is 1 when x is going from 0 to 2, and this is 0 when t is bigger than 2, right? So in this case, this is constant, and this is discontinuous. All right? This is a more difficult problem, right? You have x prime plus 3x is equal to gt. So 3 is a constant coefficient, and this gt is a discontinuous input. But here I have an initial condition, right? So the first thing we have to find is integrating factor. So what is the integrating factor in this case? Yes?
E to the 3t.
Yes, can you sign the back of the paper, please? So integrating factor will be e to the 3t, all right? Why? Because the coefficient will be 3, so you take the antiderivative and you have 3t, and you just put e to the 3t, right? So it's always this guy, which is the most important. You look into this guy, you take the antiderivative of this guy, you take the exponential of that. All right, so the integrating factor will be e to the 3t. you multiply 3e to the 3t to both sides, plus e to the 3t times 3x, and this is e to the 3t gt, right? So when you have an integrating factor, you have to multiply that to both sides of the equation. Now, what is e to the 3t times 3? Yes?
Derivative.
Yes, you can both.
E to the 3t, like the derivative of e to 3t times x.
Yes. Can you both stand at the microphone? Yes. So this is going to be e to the 3t prime. All right? Right. So, so when you multiply integrating factor to both sides of the equation, e to the 3t times 3 will give you e to the 3t prime. So e to the 3tx prime plus e to the 3t prime x will be e to the 3t gt. All right? So how can I write the left-hand side? Yes?
Using the product rule, you can write it as e to the 3t x prime.
And you?
E, yeah.
Can you set both sides at the back of the paper, please? So you have e 3tx prime is e to 3t gt. Right? Now I have to solve this equation. Right, so how can I solve this equation? Yes?
Integrate both sides.
Yes, can you stand at the back, please? So you integrate both sides, you have this. All right, so e to the 3t g. Right, so now what we have to do is to be more precise, because here you don't have the constant, right? So when you integrate both sides, you have 3 to put in. This is x at t, so you have e to x at 0. And then this is going to be integral from 0 to t of gs ds, in which gs is going to be 1 when 0 is smaller than s is smaller than 2, and 0 when s is bigger than 2. Right? You have e to the 3t x prime is e to the 3t gt. But now you have an initial condition, right? You have initial condition. Important. You have, we have initial condition. Condition. And initial condition x0 is 0. Right? So we want to use this initial condition, because in the previous way, if you use indefinite interval, you have to put a constant. Now you have an initial condition, so you have to use it. This formula will allow me to integrate from 0 to t. Right? So I'm going to integrate from 0 to t on both sides. I'm going to have a difference between e to the 3t x minus e to the 3t x at the point 0. So the initial condition x is 0, so I'm going to have e to the 3t xt will be the integral from 0 to t of gs ds. All right? Yes?
What did you get from the equation on the bottom and the equation on top?
The last equation, yes, so I have one. So this is the formula that I use. So I have f prime of t is gt, right? So I integrate both sides. So I have ft minus f0 is the integral from 0 to t of gs ds. This is the formula that I use. I have f prime of t is equal to gt. I integrate both sides from 0 to t. So to prove this, this is, so you integrate from 0 to t of f prime of s ds, and this is going to be the integral from 0 to t of gs ds. Right? This is proof. So you integrate of, so now you have to integrate with a variable. So I call this variable s if we want to fix the t. Right, so you integrate from 0 to t of the left-hand side and the right-hand side. So the right-hand side is what you have here. The left-hand side will give you, by definition, ft minus f0. And you keep the same on the right-hand side. All right? Yes?
Where did the E3 of t that was in front of the G of t go, like, when you were integrating with those things?
E3t.
Like the one that's on the right side of the bottom.
This one?
No, the bottom right, it goes E3 t, G of t.
Excellent. Can you sign the back of the paper, please? So you have E3x dx. Yes. So I made a mistake there, right? So there's all right. So here I gonna use. So if I don't have the limit, the left-hand side is just the antiderivative of the right-hand side. So you have to find a function system. Derivative is the right-hand side. But here you have the value at 0. So you have to use a definite interval, so, which means that you have to put the two limits here. So to put the two limits, you use this formula, ft minus f0 is equal to this guy. So to prove it, it is easy. So you just integrate on an interval on both sides, 0 to t. So the right-hand side will give me ft minus f0. Right? Questions? Right. So now let us go back to this guy. You have e to the 3tx minus e to the 30x0 is equal to the other to the right-hand side. So x0 is 0. Now I have this formula. I have to compute this formula, right? So I consider three cases. Case number one. Case number one, when t is smaller than or equal to 2. All right? When t is smaller than 2, gs will be 1, right? Gs will be 1 because s is from 0 to t, right? So I have e to the 3t, xt is equal to integral from 0 to t of 1 ds and dct. So xt will be t e to the power minus t. Yes?
Would you add the e to the three events of the bottom?
Thank you. Can you sign the back of the paper, please? So here you have ts. So here I have 1 over 3 e to the 3t minus e to the 0. And this is 1/3 of e 3t minus 1. So you're going to have 1 over 3 minus 1 over 3 e to the power minus 3t. Right, can you sign the back? Thank you. So when t is smaller than 2, s is 1 because s is 1 when s is from 0 to 2, right? Now I have e to the 3tx is equal to e to the 3s here, right? ds. So the antiderivative of this guy is 1/3 of e to the 3t minus e to the 0. So this is 1/3 of e to the 3t minus 1. So I'm gonna divide both sides by e to the 3t. So I have xt is 1/3 minus 1/3 e to the power minus 3t. Questions? It's okay. Case number 2. T is bigger than 2. So what happens when t is bigger than 2? Yes? No. But can you sign the back of the paper, please? But gs is not 0. gs is 0 from 0 to 2. But when s is going from 2 to t, is gs is 1 from 0 to 2. But when s is going from 2 to t, is going to be 0. So there are two intervals. Right? When t is bigger than 2, so let me write it down. So you have e3t xt is going to be the interval from 0 to t, 2 of gs ds, plus the interval from 0 to t up to gs ds. All right? So when t is bigger than 2, you have to split intervals. So you have to split this guy, the interval from 0 to t, into two intervals. The first one is from 0 to 2, and the second one is from 2 to t. Right? So, then, of course, I have e to the power 3s. All right? In this interval, g is 1, and in this interval, g is 0. So this is 1, this is 0. All right? So I can forget the second interval. And this gives me 0 to 2, e to the 3s ds. So this gives me 1/3 of e to the 3 times 2 minus e to the 3 times 0. And this is 1/3 of e to the 6 minus 1. Right? So xt will be e to the power minus 3t over 3 e to the 6 minus 1. And that's it. I explain again. When t is bigger than 2, the right side is the same. The left hand side, I have to split it into two intervals. The first interval is from 0 to 2, and the second interval is from 2 to t. Yes?
We're saying t is greater than 2, why do we consider the interval from 0 to 2?
So, yes, good question. So, when t is bigger than 2, right? When t is bigger than 2, the interval from 0 to t will be the interval from 0 to 2 plus the interval from 2 to t. Right? The formula is the following. The interval from a to b of a function fs ds will be interval from a to c of a function fs ds plus an interval from c to b of a function fs ds.
Sorry, I follow that, but if we're saying t is greater than 2, why do we consider the part from 0 to 2?
So when t is bigger than 2, right? So this interval is good, right? No. So here you have 0 to t, and this is the number 2, right? So this is the function gs times e to the power minus 3s, right? So the interval from 0 to 2 will be this area, right? So this area will be the sum of two areas. The first one is from 0 to 2. The second one is from 2 to t, right? So this is why you have to split the interval from 0 to t to the interval from 0 to 2, and the interval from 2 to t to t to 2. It's clear? So after I split it, the second one is 0 because s is bigger than 2. S is bigger than 2, meaning that gs is 0. It's clear? So this is 0, and the first one will be 1. So I try to let me explain this again. All right. So this is the graph of the function gs e to the power minus e to the 3s, right? And you integrate that from 0 to t. And this is 0 to t. All right? This is the interval. So what is the definition of the interval? The definition of the interval is just the area of the shape the curve form from 0 to t, right? So this shape this interval will be the interval from 0 to t gs e to the 3s ds, right? The interval is nothing but this area. When you are computing the interval, you are computing the area of this shape, right? Now, because t is bigger than 2, all right? The number 2 is here. So this area is the integral from 0 to 2 of gs e to the 3s ds, right? And this integral will be this area will be the integral from 2 to t of gs e to the 3s ds, right? So computing the integral from 0 to t, meaning that you compute the area of the whole thing, but the area of the whole thing is the sum of the area of the first thing and the area of the second thing. The first thing is the integral from 0 to t, 2, and the second one is the integral from 2 to t, right? Now, this is why we can split this interval. So when t is smaller than 2, right? When t is smaller than 2, the area is just here, so you cannot take a sum. Right? So for the first interval, s is running from 0 to 2. So s is running from 0 to 2, meaning that gs is 1. For the second interval, s is running from 2 to t. But s is 0 if s is, gs is 0 if s is bigger than 2. So this is 0. So what you do is you compute the first one, and this gives you this number. It's good? Yes?
Why wouldn't you like subtract if you're trying to find like when it's greater than 2?
When is this?
Like subtract the first interval.
I don't understand the question. So what you
Right.
subtract with?
If t is greater than 2,
Yes.
then why are we adding both? When we're just trying to find what the integral is when t is greater than 2.
So when t is greater than 2, right? So this area is the area of the one from 0 to 2 plus the area from 2 to t, right? So this is why you add them. But if t is, so your question should be the following. So when t is smaller than 2, why don't you subtract the 0 to 2
Yeah.
to 2, t to 2, right? But this is the same interval, right? Right, because the g is defined, remember that g is defined to be 1 when s is from 0 to 2 and 0 when s is bigger than 2. This is why you add, right? So you add one which is smaller than 2 and one which is bigger than 2.
But that would be like 0 to t. That's what we're trying to find.
Yes, this is from 0 to t.
Yeah.
Right.
Is that what we're trying to find?
Yes,
That was after like 2.
because 2 is the number here.
Okay.
No? Alright, so let's try to compute something else so that you understand. So you understand how to compute this, right? So now let us try to review a little bit about adding subtracting intervals. So I'm gonna give you one example so that you can review this adding and subtracting interval. So review. Of interval. All right. So I'm gonna give you a function which is simpler without an exponential, right? So I'm gonna consider the function gt, which is 1 when t is from 0 to 2. Right? And which is 0 when t is bigger than 2. So I want to review this because this is important in solving like differential equation with discontinuous interval. So I'm gonna try to solve this. I have this function and I compute ft, which is the integral from 0 to t of gs ds. Right? All right. In this example, so let's just forget about. I have this function. I have the function gt, which is defined to be 1 from 0 to 2, and this function is 0 from 2 to anything which is bigger than 2, right? And I have to compute the integral from 0 to t of gs ds. All right? So how many cases do I have to consider? Two cases, right? Case number one. So let me consider the more difficult case first. T is bigger than 2. All right? So this is 0, and this is 2, and this is 1. So the function g will be like this, right? So the graph of the function will be this line and this line. So this is graph of GS. All right? It's good. So this is the graph of GS. So this is 1 when TS is going from 1 to 2, and this is 0 over there. All right? So now I want to compute the integral from 0 to 2. Right? 0 to t, sorry. So this is going to be this area plus this area. But this area will be 0. This is what happened in the previous case. Right? So when t is greater than 2, the integral from 0 to t of gs ds, which will be the integral from 0 to 2 of gs ds plus the integral from 2 to t of gs ds. Right? So you add two in area. The first area is the area forming by this graph from 0 to 2, and the second one is from 2 to t. Of course, this is 0 because here you have nothing here, right? Because the function is 0. So here this is 0. So here you have integral from 0 to 2 of 1 ds, and this gives me 2. So when t is bigger than 2, this area is always 2. This is a fixed constant because everything else, the area of anything else that is bigger here, bigger than 2 is 0. Now, what is going on when t is smaller than 2? If t is here, the area that you have to compute is smaller. Right? So you don't subtract because you compute from 0 to t. If you subtract, it's the same. It's the same business, right? Case number 2, t is smaller than 2, right? So I'm going to show you that if I subtract, it's going to give me the same result. So when t is smaller than 2, the integral from 0 to t of gs ds will give me integral from 0 to t of 1 ds, and this is t. All right? So when t is smaller than 2, this integral is t. If I compute explicitly, I don't subtract. Now let me try to subtract, because we know that the integral from 0 to t is this area. So this area is the integral from 0 to 2 minus the integral from t to 2. So what is this? So by subtracting, a different way to compute. So we're going to subtract the area from 0 to 2. So subtract the area from 0 to 2 and the area from t to 2. Right, so I'm going to subtract the area from 0 to 2 and the area from t to 2. So I'm going to have the integral from 0 to t of gs ds is going to be the integral from 0 to 2 of gs ds minus the integral from t to 2 of gs ds. All right? Now, this guy is integral from 0 to 2 of 1 ds minus the integral from t to 2 of 1 ds. So the first one gives me 2 minus 0. The second one gives me minus of 2 minus t. All right? So this gives me t. So if you subtract, it gives you the same result, right? So this is t, and this is t. This is your questions, right? Right. So basically, for integration, to avoid confusions, you just have to keep in mind that an integral is nothing but computing the area, right? So in this case is a simplified version of the previous computation in which I choose g to be 1 from 0 to 2 and 0 for t is bigger than 2. So when t is bigger than 2, so I compute the area, but the area will be the area from 0 to 2 plus the area from 2 to t. But the area from 2 to t is 0 because it is like this, all right? It is always 0, it's always this line, and the area is, there's no area there. So this is 0. So the first one is always 2, when t is smaller than 2. So you compute this area. This area will be t if you do it in a straightforward manner. But if you don't like it, you want to subtract the big area here with the small area here. You get the same result, right? Other questions? It's clear? So this is the same principle that we used in the previous computation. All right, questions? It's clear? It's fine. Right, so to summarize, we have learned linear differential equation with constant coefficient and constant forks, homogeneous or zero forks, discontinuous forks. And this, for the discontinuous case, the key principle is you know how to compute the area. So integral is just, the integral of a function is just the area of the regions that is formed by that function with the axis, right? Questions? Now let us try to learn another thing, which is the application. Right, so population dynamics, so 1.8, population dynamics. Right, so the very first application of differential equation is population dynamics, right? So you look into any textbook of population, differential equation, you find the first example to be population dynamics. Of course, this is not just human. This is also like the population of ants, or insects, or even birds, right? And population dynamics is a very active area of research, which is nowadays become collective behavior. So in the beginning of our class, we learned about the population dynamics of Washington, D.C. Let us try to formulate this in a more precise manner, right? So PT, this is the population of anything, right? So this is a function of time. PT is a function of time. All right. So you consider any population, the population of the people in this data city, or you consider population of ants in the park, or you consider the population of birds. So when you consider population, this is of course a function of time, right? So you have to have a function which depends on time. So dp over dt, p prime, p dot of p prime. So this is the growth, the rate of change of the population. All right. So you compute the derivative of this function. This is called the rate of change of this population, right? So then you have pt over dt, and you have 1 over p, which is p prime over p. This is growth rate. So the growth rate is the ratio between the rate of change and the population, right? So for instance, example. So the population of the US, so it's going to be 29 million. And every year it is increasing, like 2.7 million. All right. So for instance, the population of the US is 296 million. All right. And every year you have an increase of 2.7 million. So the rate of change, the growth rate, will be 2.7 over 296, and this is 0.9%. This is this. Right? So the population of the US is 296 million. Every year is increasing with a number 2.7 millions. So this is going to be the rate of change. And the growth rate will be 2.7 over 296, and this is 0.9% of the population, right? So the growth rate is the percentage of the change over the total population, right? Right. So now let's. So if the growth rate, is a constant, okay, we then have p prime is equal to the p prime over p is equal to k, right? So if this rate is a constant, if this percentage is fixed for all years, so I have a constant, right? Then p prime over p is a constant k, and we have the differential equation, and we have the differential equation. Differential equation: p prime is equal to k p, or p prime minus k, p is equal to 0. So this is the equation that we've studied already, right? It's clear. So if the growth rate, I mean the percentage of growth of the population of the US is a fixed constant for all time, then you're going to have the equation p prime over p is k, right? Now, in this case, you're going to have the differential equation, p prime is equal to kp, and this can be changed into p prime minus k, p is 0, all right? So I'm going to write this equation over here. So I have p prime minus kp is 0. This is the equation that we have. So what is this now? What is the type of this equation? Homogeneous, yes, and linear, and first order, and constant coefficient, yes. So this is first order, right? This is linear, and this is homogeneous, and this is a constant coefficient, right? So what is the integrating factor for this equation? For this equation, yes? Yes?
Just e to the k t.
No. Yes?
E to the minus k.
Yes. Can you say the back of the paper, please? So the coefficient here will be minus k. So you integrate that, you have minus kt, and the integrating factor will be e to the power minus kt. All right? All right, so we're gonna meet again on Tuesday. Have a nice weekend.